Students, good morning. In this session, I will solve some important questions from the exercise. See the first question. Solve the determinant 2, 3, minus 2, 3, 4, 0, 1, minus 1, 5. You can see it's a determinant of order 3. Okay. First, take the element 2 into, delete the corresponding row and corresponding column like this. You need to delete this row and this column. What you will get? Okay, 4 into 5, 20, minus 1 into 0, minus 0. Okay, alternative plus, minus, plus. Okay, what's the second element? 3, but need to take minus. So, minus 3 into, okay, then in the next step, you need to delete first row and second column. Then what you will get? 5 into 3, 15, 1 into 0, minus 0. Okay, then next to plus into minus, it's minus 2 into, okay, the next step you need to delete the third column and the first row. Okay, then 3 into minus 1, minus 3, 1 into 4, it's 4, but formula minus is there, middle, right? Okay, now simplify. 20 into 2, it's equal to 40. 15 into minus 3, minus 45. Here see, minus 3, minus 4, minus 7. Minus 7 into minus 2, it's equal to 14. Okay. The next step, see, 40 minus 45, minus 5 is remaining. Minus 5 plus 14. Okay. Answer is equal to 9. See the next question. Determinant 3 minus 1 2, 1 3 minus 2, 1 4 3. Simplify. Here it's equal to 3 into, then delete the first row and first column. 3 3 is a 9. 4 into minus 2, actually already one minus is there, but 4 into minus 2, minus 8, minus into minus, here you will get 9 plus 8. Clear? See, in the middle formula minus is there, minus into 4 into minus 2, minus 8. Minus into minus, it's equal to plus 8. Okay. Then actually formula itself minus is there. Okay, because you need to take alternative plus, minus, plus, minus into minus, plus 1. Okay. Into second entry, see, delete the second column and first row. 3 into 1 is 3. Minus, minus 2 into 1 is minus 2. The formula itself one minus is there. Minus 2 into minus 1, it's equal to plus 2. Okay. Then last entry, plus 2 into, delete the third column and first row. 4 into 1 is 4. 3 into 1 minus 3. Okay. Simplify this. Okay. Here see, 9 plus 8, it's equal to 17. 17 3s are 51. Okay. Then 3 plus 2, 5 into 1, it's equal to 5. Okay. Then see here, 4 minus 3, 1. 2 into 1, it's equal to plus 2. Okay. Then 55 plus 1, 56 plus 2, it's equal to 58. Therefore, value of this determinant is equal to 58. See the next question. You need to find the value of the determinant 2, 0, 0, 0, 4, 0, 0, 0, 5. Here see, principal diagonal entries 2, 4, 5 is there. Observe the entries below the principal diagonal and above the principal diagonal. Here, both sides of the principal diagonals are equal to 0. See the property. By the property of the determinant, that says in a determinant, if both sides or any one side of the principal diagonal entries are equal to 0, then determinant value is equal to product of the principal diagonal entries. Here clearly you can see the principal diagonal. Both sides of the principal diagonal entries are equal to 0. Therefore, its determinant value is equal to product of the principal diagonal entries. What's the product? 2 into 4 into 5. Okay. It's equal to 4 to 8. 8 into 5, it's equal to 40. See the next question. You need to find the value of the determinant 1 2 minus 1, 3 1 minus 4 and 1 0 minus 2. Okay, see it's equal to first entry 1 into, you need to delete the first row and the first column. Okay, so remaining is here 1 into minus 2 minus 2, okay, minus 4 into 0. Okay, minus 4 into 0, its value is equal to 0. Second entry minus 2, because you need to take alternative plus minus plus. Okay, minus 2 into, the next step, delete the first row and the second column. Okay, then you will get 3 into minus 2, it's equal to minus 6, minus, this is by formula, minus 4 into 1, it's minus 4. Okay, minus 4 into 1, minus 4, but already 1 minus here. Okay, minus into minus, its value is equal to plus 4. Okay, then plus into minus, minus 1 into, okay, you need to delete the first row and the third column. Okay, this column you need to delete. Then 3 into 0 is 0 minus, this is by formula, 1 into 1 is equal to 1. Next step, simplify. Minus 2 minus 0, minus 2 into 1, its value is minus 2. Then minus 6 plus 4. Okay, its value is minus 2. Minus 2 into minus 2, its value is equal to plus 4. Then 0 minus 1 is minus 1. Minus 1 into minus 1, its value is equal to plus 1. In the next step, okay, 4 plus 1, 5 minus 2, its value is equal to 3. Therefore, value of the determinant is equal to 3. See the next question. Solve for x. Given determinant 1 2 3, 2 x3 and 3 4 3 equal to 0 is given. Using determinant expansion, you need to find this x value. Okay, first expand this determinant. 1 into, take alternative plus minus plus, 1 into, here delete the first column and the first row. 3 into x is 3x, 4 into 3, 12, but minus is there, minus 12. Then minus 2 into, delete the first row and the second column. 3 2s are 6, 3 into 3, 9, middle minus. Okay. The next plus 3 into, okay, you need to delete the first row and the third column. 4 2s are 8, 3 into x, 3x. Okay, so here you have to write minus 3x. The next step, okay, right hand side equal to 0. Next, simplify. 3x minus 12, 6 minus 9 is minus 3, minus 3 into minus 2, it's equal to plus 6. Next, 8 3s are 24, okay, 3 3s are 9, but minus is there, so it's equal to minus 9x equal to 0. The next step, see here, 3x minus 9x minus 6x minus 12 plus 6, it's equal to minus 6. Okay, minus 6 plus 24. Okay, it's equal to plus 18 is equal to 0. In the next step, shift minus 6x to right hand side. So here you will get 6x equal to 18. Taking minus 6x to right hand side, minus 6x become plus 6x. 18 is remain. Okay, x is equal to, dividing both side by 6. Okay, x is equal to 3 because 6 3s are 18. Therefore, x value is equal to 3. See the next question. Solve for x. Determinant given as x01, 0x0, 10x equal to 0. Using determinant expansion, you need to find x value. Take plus, minus plus, then expand x into, delete the first row and the first column. X into x, it's equal to x square. Okay. 0 into 0 minus 0. Next, minus 0 into, okay, no need to simplify. For your reference only I am going to simplify, because 0 into any number you will get 0 only. Delete the first row and the second column. So 0 into x is equal to 0, 1 into 0 is equal to 0. Totally this answer is 0. Okay. Then plus 1 into, okay, again delete the first row and the third column. Remaining is 0 into 0 is equal to 0, minus 1 into x is equal to x. Okay. Now simplify. X into x, x cube. Okay, right hand side here 0 is there, x cube. Here 0, 1 into minus x is equal to 0. From here take x outside, what is remaining? X square minus 1 is equal to 0. Okay, clearly this implies either x is equal to 0 or x square minus 1 is equal to 0. Okay. The next step, see, that implies x is equal to 0 or x square minus 1 equal to 0 is there. Shift minus 1 to RHS, will get x square is equal to 1. That implies x is equal to 0 or x square equal to 1. In the previous problems is x square equal to 9. You are writing x equal to plus or minus 3. Similarly, x square equal to 1, that implies x is equal to plus or minus 1. Because plus 1 square is equal to 1, minus 1 square also is equal to 1. Therefore, we are writing x is equal to plus or minus 1. Okay. Therefore, x is equal to 0, 1 and minus 1. 3 values are possible. Okay. This is the solution. See the next questions. Evaluate the following. Determinant is given. 2011, 2012, 2013, 2014. Row entries. Okay. You can see the entries. Without a calculator, it's little difficult to calculate the values. We know how to calculate the determinant value. Product of diagonal minus product of non-diagonal. But here big numbers are given. To solve this problem, we need to use the properties of the determinant. Okay. See here. You can see row 1 with the entries 2011, 2012. Here row 2 is there with the entries 2013 and 2014. Observe row 1 and row 2 and see the corresponding elements. 2011 corresponding element is 2013. 2012 corresponding element is 2014. You can see with respect to their corresponding elements, their difference is 2, right? 11, 13, 12, 14 is there. So, first apply the operation to row 2 such that, okay, R2 minus R1. Okay, R2 minus R1 means you need to subtract the corresponding element of R2 and R1. Just see, you are applying operation to R2 only. So, R1 entries remains same, that is 2011, 2012. Okay. Now R2 minus R1, subtract the corresponding elements. 2013 minus 2011, 2 is remaining. 2014 minus 2012, again here 2 is remaining. Okay. In the next step, again use the properties of the determinant. The fourth property says, if any row or column has the common element, it's possible to take that constant term outside. In the second row, 2 is the common term, right? So, the next step, see, 2011, 2012, take this 2 outside. Okay, taking 2 from the R2, keeping that 2 outside. Here 1 is remaining, here 1 is remaining. Okay. Here taking 2 means it's not possible to multiply this 2 to 2011 and 2012. By the fourth property, if any row or column has the common element, it is possible to take that common element outside. Row 2 has the common element, so you are taking that constant outside. Then here 1 is remaining, here 1 is remaining. Now it's easy to simplify the determinant. The next step, see, it's equal to, okay, 2 outside, product of diagonal entries 2011 into 1, 2011, okay, minus this by formula 2012 into 1, it's equal to 2012. It's equal to 2 into 2011 minus 2012, its value is minus 1. So 2 into minus 1, this value is equal to minus 2. Therefore, value of this determinant is equal to minus 2. Okay. First you need to apply elementary operation. After that you need to simplify. Okay. Here you are using property of the determinant, that's a fourth property. If any row or column has the common element, it's possible to take that common term outside. Then simplifying this determinant, then common term see 2 into minus 1, answer is minus 2. The next question. Evaluate the determinant 5431, 5433, 5435, 5437. Similar to the previous question. Okay. First, see the entries. Here row 1 entries and row 2 entries. Observe the corresponding elements of row 1 and row 2. Here 4 difference is there, right? 35, 31, 37, 33. Okay. First use the elementary operation. Apply the operation on R2 such that R2 minus R1. Subtract the corresponding elements of R2 and R1. Since you are applying operation to R2 only, R1 remains the same. So 5431, 5433. Okay. Why? Because you are applying operation to R2 only. Then simplify. 5435, 5431, 4 is remaining. 5437, 5433, again 4 is remaining. In the next step, use the property of the determinant. If any row or column has the common term, we can take that common term outside. So in the next step, from the second row, taking 4 outside, then first row remains same, 5431, 5433. What is remaining? 1, 1, because you are taking that 4 outside. Okay. Now simplify that determinant, keeping 4 outside, multiply 5431 minus 5433. Okay. 31 minus 33, here it's equal to 4 into, okay, minus 2 is remaining. Then in the next step, this one clear, right? Product of diagonal entry minus product of non-diagonal entry. Okay. So minus 2 is remaining. 4 into minus 2, its answer is equal to minus 8. Therefore, value of this determinant is equal to minus 8. See again, similar to the previous question, you need to evaluate this determinant. Okay. Directly observe the row 1 and row 2. Again, see, it's not necessary to apply the operation to row 2 only. You can apply, see, columns, right? Here, if you observe C2 and C1, again you can see difference 1, 1, right? You can apply operation to column only. Okay, but here I am applying operation to row 2 only. Observe each elements, their difference. R2 and R1, observe the corresponding elements. Difference is equal to 2. Okay, so applying operation to R2 such that R2 minus R1. That means you need to subtract the corresponding element of row 2 from row 1. Okay, apply the operation 3200, 3201. Row 1 entries remains the same because clearly this says you need to subtract R2 elements. Okay, 3202, 3200, here 2 is remaining. 3203, 3201, here again 2 is remaining. In the next step, use the fourth property. If any row or column has the common elements, it's possible to take that common elements outside the determinant. In the second row, 2 is the common element. So take 2 outside. Remaining is 3200, 3201. Here 1, 1 is remaining. In the next step, evaluate the determinant value. It's equal to 2 into product of diagonal entries 3200 minus product of non-diagonal entries 3201. 2 into subtracting here you will get minus 1. 2 into minus 1, answer is equal to minus 2. Therefore, value of this determinant is equal to minus 2. See the next question. Evaluate the determinant 85, 88, 91, 86, 89, 92, 87, 90, 93. Observe the row entries R1, R2 and the last row R3. Compare R1 and R2. Their difference is 86, 85, 1, 89, 88, 1, 92, 91, difference 1. R3 and R2, 87, 86, 1, 90, 89, difference 1, 93, 92, difference 1. So you can simultaneously apply the operation R2 minus R1 and R3 minus R2. Suppose you are comparing columns C2 and C1, 88, 85, 3, 89, 86, 3, 90, 87, 3. Again C3 and C2, 91 and 88, 3, 92, 89, 3, 93, 93, difference 3. So you can compare rows or columns. Answer is same. Okay. I am comparing rows. I am applying operation to R2 first. R2 such that R2 minus R1. And simultaneously applying operation to R3 such that R3 minus R2. Okay. Now simplify. Since you are applying operation to only R2 and R3, R1 entries remains same. What's the row 1? 85, 88, 91. Next R2 minus R1. 86, 85, 1. 89, 88, 1. 92, 91, 1. Just subtract the corresponding elements. Next R3 such that R3 minus R2. R3 minus R2. These two rows. 87, 86, 1. 90, 89, 1. 93, 92, 1. Okay. Now see the determinant. Whatever may be the first row entry, observe second and third row entries. Second row entry 1, 1, 1. Third row entry 1, 1, 1. You can say that two rows are identical. Property of the determinant says in a determinant if any two rows or columns are identical, determinant value is equal to 0. Here clearly you can see R2 and R3 are identical because each element is 1 only. Corresponding elements are equal, that means identical. So here you can write determinant value is equal to 0. By the property of the determinant, directly you can write value of this determinant is equal to 0. Therefore, value of this determinant is 0. These are some important 2 and 3 marks questions. The next session, I will solve some important 4 marks questions under the concept properties of the determinant. Thank you.